Hi, today I'm sharing with one of the most important concept in sciences, engineering, economics, biology. Okay, so this is one of the most mysterious and one of the most important concept. I think in your life, somewhere you always use this concept, and this is known as the Fourier transformations and Laplace transformations. Here I'm discussing only main difference between Fourier transformations and Laplace transformations, and I'm telling you uh, I tell you where you need to use these concepts. Okay, even you are doing some real time experimentally, or you are looking some real time theoretical solutions, or even once you are reading those things, then before that you need to know why you are doing this thing. Okay, so let's start from Laplace transform and Fourier transformation. So sometime you are thinking, okay, one of them is sufficient for doing everything. Okay, so once you are looking at Laplace transformations, oh, it's okay to doing whatever you like to do. Okay, but luxury is for the transformation is easy. Okay, that's why we use Laplace transformations. Okay, so this is the part of integral transformations. Okay, both of the things. Okay, it comes from integral transformations. Okay, and some other transformations like Mobius, and some other transformations like Henkel and Mellon transformations. Okay, and there's many other transformations also. So let's discuss first of all those two, and then mainly a main difference, and then hope so guys you somewhere in your life you are using these two transformations. So I'm discussing with the integral transformations form first of all. Okay, and I try to discuss with you slowly. It's like a integral a to b. Okay, these are two limits. Okay, so between a and b limits, and this is called k of s comma t. Okay, and f of t. Okay, and delta t. Okay, so these transformations are varying between those two limits, and this is k of s comma t is called kernel. Okay, and f of t is your functions. Okay, you need to use these transformations, okay, for functions, and this is equal to a integral transformations. This is definition of integral transform. And so if I'm interested in Laplace transformations, so you need to just put some limit here, and you need to choose some kernel. Okay, and kernel is something called your smallest part. Okay, and using that part you maybe build a big thing. Okay, that is known as a kernel, or in you may be called a smallest basis, something like that. Or if you need to understand more, there is some in group theory also a name, but I don't know that I can't remember right now exactly name. So but it's kernel, and then it's something like basis. Okay, so once you change a kernel, so your transformations is changing. Okay, so then first of all choose uh, kernel. Okay, so what is mean by this is known as a transform. So I maybe says you have a two spaces, or you maybe have two places. I call a space, this is called a t space. Okay, this is t space, and here is called your s space. Okay, so you are transferring from this thing to here. Okay, you are transferring, that's known as the transform. Okay, so you are transferring from one thing from this place to this place, and s is called known as the parameter, belongs to some domain on the real line or in the complex plane. So what is the difference between these two transformations? Once you put a equal to a 0, this is some, okay, b equal to infinity, some upper limit or infinity, whatever. Okay, and you choose a and b. Okay, first of all you select, then you choose k of s comma t. Okay, something like e raised to power minus st. Okay, this is exponential functions. And in some other cases you maybe choose a is equal to minus infinity and b is equal to plus infinity, and k is of s comma t is equal to e raised to power minus I st. Okay, minus I s t. Okay, so these transformations is known as the Laplace transformations, and these transformations is known as the Fourier transformations. Okay, that's all. These two are the transformation. So what is the main difference? Okay, so how does it look like? So I maybe note this Laplace transform like this. Okay, this is equal to, this is definition. Okay, so this is 0 to infinity e raised to power minus st f of t dt. Okay, and Fourier transformation like this equal to minus infinity to plus infinity e raised to power minus ist. Okay, f of t dt. Okay, this is known as the integral transformation. One of the reason you need to solve the integral. Okay, you always need to solve. So what is the difference between those two transformations? So main difference is just look here limits. Okay, you just need to mostly look on the limit. Okay, or you need to look on the domains of functions. Okay, so once you are looking some functions, then look at domains or look at limits. Okay, then your function is defined based on that. So this is going from 0 to infinity, and this is going from minus 0 to minus infinity to plus infinity. Okay, so then how we interpret in real life? Okay, so if you are doing some experiment in front of your eyes, and you know you start from something here, so you use a Laplace transformations. And if you don't know if something is coming from past and it's going away, something like gravitational wave, okay, first of all time observe. Okay, so coming from past and reaching to earth and stretching and compressing of earth and going away. So this kind of simulation is doing and helpful for finding out things. Okay, finding a signals and all those things using a Fourier transformations. We can't use a Laplace transformations there. Okay, if you start some wave from here and sending it for the universe, then you maybe use a Laplace transformations, and Laplace transformation is easier than a Fourier transforms. That's why we choosing a Laplace transformations. Okay, so example like if you like to discuss example. Okay, so someone out of the four, which one is a Laplace transformation? Where B use Laplace transformations, Laplace transform, and your options like okay, first of all something 1 2 3. Okay, it's 3 and whatever figure you all got. Okay, so one of them going like this. Okay, another is going like this, and another is going like this. Okay, so you need to always remember third one is the correct option, because Laplace transform is going to 0 to infinity. Or if I put t is equal to 0 here, okay, t equal to 0 and t equal to 0 here. So if you know some functions like this, okay, in your real life, even whenever you are performing experiment or whatever you are doing, okay, and you are getting some value which you don't know, okay, in real life, so you just need to use Laplace transformations. Or if you don't know if things comes from another place, then you need to use a Fourier. And this is like a real life case, so you need to understand things in real life. So this is the huge things you need to know about before you are doing something. Okay, and this is extremely important concept whenever you are dealing this kind of things. And then one of the inspirational things I maybe says, this is the this from Feldman list. Okay, Sadiq Bilani, once he tried to solve a solution of plasma equations. Okay, for solution this equation he got Nobel Prize. He was got in 2010, I think so. So Hyderabad, okay, one of the things in Hyderabad, India. So he's looking the solution of the equations and he's spending many times, but and he already announced within few days he solved the solution, he solved equation and put the solutions. but he solved thousands of pages, but he can't read the solution. One night he sleep, and by chance he got in his dream, okay, oh, if I use an inverse Fourier transformation, I maybe solve the problem. And that's all about. We solved the problem. He and he got a novel. He got a field medal. Okay, field medal is a mathematics Nobel Prize given for those mathematician, extremely bright mathematician, age is less than 40 years. Okay, guys, hope you enjoy this video.